Okay, so welcome to our advanced materials class, and that's just the beginning. So the first thing I'm gonna ask you to do, let's make a new folder here. Let's call it my materials. In my case, it's Moo materials. That's fine. Let's see. Let me just quickly change here. All right, my materials. Now inside of it, let's create our first material. Right click, material, and underscore. I know. Let's do a rock face or rock face, and let's open it up. So if you don't remember, here we have our nodes for a material. The ones we are using a PBR physics-based rendering technique that is, well, it's the way that the computer is calculating the materials in here. And for PBR, we are using real life physics to make these materials happen. And the most important things that we have in PBR, they're always base color. That's literally the color of things, and it doesn't have to be a single color. We can have multiple colors. So color is one very important. Metalness or metallic, if it's metallic or it's not, so it's 0 or 1. In this case, it's not metallic, 0. If we want to turn into metallic, we just put 1 here.
No, no, it's all good.
And now you can see it's a material. It looks more shiny or more metallic. The roughness is the next step here. That's very important. So right now we have roughness. We go from 0 to 1. So if it's 0 rough, now we're gonna have a mirror because it's metallic and it's super well, not rough at all. And we have the opposite. If we have roughness 1, now although it's metallic, it looks pretty weird. But yeah, there we go. So we have this flat looking or no um, glow anywhere, or it's not reflecting anything because it's too rough. Those are the three main ones, okay? Base color, metallic, and roughness. Then we have some other things that are important as well. Specular, this one is very useful if you want to create water. So if my specular is 1, we should see, yeah, maybe not with this form here. If we have more bumps, then we could see, but with a specular will create like a white glow somewhere, so it looks like it's moisty. At 0 you have nothing, and 1 you have a lot, and any value in between will work. The same with roughness. Metallic is the only one that's either 0 or 1. All the others, any value between 0 and 100%, or 0 and 1, it's okay. MSIF color, this one, it's also pretty interesting. So for example, let's say that I have here, you probably remember from last semester, but anyhow, let's say they want to create a glowing, right? There you go. So I want to create a glowing material. I'm going to use MSIF color for the glow. So right here, if we drop it into a cube, and if we also change our light, our directional light, I would just make it pretty small, pretty low. Now we just have to wait here. Is it saved? So it's applied. Okay, so now you can see we have this emissive light coming out of the material here in this form. So this is pretty cool. We can also use it with a mask. And you can see it's literally emitting light. We can see the light here all over the place. And we can also do some cool things. As you probably remember, we can add here a multiply node, for example, and connect this one in there. And now multiply here, let's say instead of 1, I want it 5 times brighter. So let's do 5. It's gonna become brighter. Or let's do crazy, like 100. It's gonna turn really bright. And now when I save, we're gonna see the difference. Oh, super bright. Now we have a lightsaber light in here. Okay, so we can play with those things. Um, let me see if I can show you something else here. I haven't planned. Okay, this one might be interesting. So if I multiply these two, we're gonna have a different form. Yeah. So if we have masks like I have here, whenever I have white, I will have the color. Where I have black, I'm not gonna have the color. So we can create all sorts of looks with it. Let's imagine, well, we can produce a emissive material later. I think I'm getting ahead of myself here. Let's go item by item here. Opacity and opacity mask, those two, they are grayed out because something very important that I don't think we discussed in MEDA 280, it's right here. Okay, so here on the details panel, these are the details of the material as a whole. Okay, so this box here, that's the although it's the output, but it's the input location here, and also the output on the other side here, on how those nodes here should behave based on the details we have chosen here. For example, material domain. Let's see what we have here. We have a surface. That's the majority of the materials we're going to create there, surfaces. But we also have here a decal, the one that we're going to use later to create decals. Light function for things that are just interacting with light. Volume, this one, if you want to create a volume, it's similar to decal, but you can apply the decal in the whole volume. Post processes, if you're using post processing, so you can just have a material that only changes while under the post processing process. And user interface, this one's to use with, well, UI, user interfaces, if you need like a specific material that doesn't react with light, for example, and so on. But there are many ways that you can use all of these. We're just gonna learn these two here because they're the most used. Okay, and yeah, that's it. We also have here the blend mode. That's very, very important. So the blend mode will change usually when we change, let's change here from surface to decal. So you're gonna see how this box here will change. So now we have only the world position in there and nothing more. Light function. Okay, so we have different nodes appearing depending on which mode we choose. So this one looks even weirder. So let's choose surface. That's the basic one. And here opaque means that, well, it's opaque. We have no opacity. Remember, opacity means you're gonna ask more of your computer to render things. Later we're gonna talk more about it, but everything that is behind a transparency, we're gonna have to, so let's say we have a window, a glass window, and behind the window we have a wall. So if the window is not transparent, we're just gonna render the window, and the wall behind it, it's just gonna be ignored by the computer because you cannot see it, so it's not gonna render. However, if we do have a window with the transparency on the glass, we're gonna have to render it twice. One time we're gonna, or actually three times. One time we're gonna render the glass, the other time we're gonna render the background, and then we're gonna render again both together. So every time that we have overlapping um, transparencies, we're gonna be asking a lot of our computers. So we should avoid to the most using transparencies. Okay, so here if we change from opaque to masked, now, the only thing that changed here is now that we have an opacity mask. Someone put on the chat that the terrain was not getting, or the mask brush was not showing up on the terrain. It's probably because you don't have it as masked with a landscape. So here's landscape opacity mask, I think it's how it's called. Visibility mask. Okay, so if you set up your landscape material like this with a masked blend mode and also with the landscape visibility mask under opacity mask, you're gonna have access to the visibility brush, or sorry, the mask brush or opacity brush. Now I don't remember how it's called. Okay, so masked is one that we're not gonna use very often, but let's say that you have alpha in your drawing. um, maybe like it's a floating mask. I don't know. Do we have a texture here? Texture sample. Let me see. We probably have something in here. Yeah, there you go. So we have this thing here. If we plug into the base color, and let's make this one square. Okay, so that's how it looks. Everything that is empty. So let's open here the texture. Double click. So everything that's empty that we are on the alpha channel, it's rendering as gray here on the material, right? But let's say that we want to mask out those things and just keep the target in here. So we can pull here from the alpha channel and plug into the opacity mask. So we're literally gonna destroy everything that is on the alpha channel. They're just gonna be empty. Okay, it's not transparent, it's empty. Okay, that's the opacity mask. So we are not asking the computer to render twice this area here because we are using the opacity mask. However, let's see here a change. So if I change from masked to translucent, uh, now the opacity mask is gone, so we are back to the areas that have alpha just being ignored and rendered in black or gray or whatever color we have in here. In this case, it's black. So if I connect my alpha channel to the opacity channel, now we're gonna see that is, wow, in theory we have the same effect, or visually it looks the same. But in this case here, this area, it's being rendered. The other option here, it's not being rendered at all. Okay, so the other one's more performant, but sometimes you want some opacity. In this case, my opacity is 100%, meaning that's totally transparent, so it looks exactly like the other one. But let's say you have 20% transparency, then we're gonna see something in here, right? So that's the main reason why we should uh, use one or the other. um these ones here, to be fair, I don't know exactly what they do. I never use them, so I just stick to those three ones here. They are the most important ones. Let me show you something else here that's interesting. So here I'm back to my masked version, and we can see here that as usual, a static mesh or a material in general has only information on its front face. So let's change here to a panel. There you go. So here, instead of having the cube, I'm using a plane. So we can see that behind the plane, the normals, they are not rendered at all. Okay, so all the visual is always on the front of our model. And that's on purpose because we don't want to render any things that we cannot see because they're behind. So the computer, the engine, will consider all the materials one-sided, okay? Meaning that we are only rendering one side. But sometimes you have, I don't know, maybe something that's floating around. Let's say that this target here is part of my wayfinding in the level, or maybe something, I don't know, UI or whatever. Or maybe instead of a, a target, it's a leaf of a tree that we're going to use later on our foliage, so on. So that's why the two-sided here really matters. So right now it's one-sided. If I click here now, oops, oh yeah, it took a while to to render, but it's here. Okay, so now I have it two-sided. It's basically the same image, but now also on the back of the object. And another huge thing here that might make a difference for you. So notice here, now we have a drop shadow. Okay, our light is coming from the back here in this specific viewport. Um, so without the two-sided, I don't see a shadow because, well, the side that's invisible does not cast a shadow. So maybe you face this problem while building your environments, your cave, that you have some sunshine, some light shining through
Why aren't you
your
going to school? What do you
your
mean? Why aren't you going to school?
meshes.
What do you mean? Why
Because
aren't you going to school? I was
someone has the
getting
mic open. Can you please
woken up.
turn it off?
It's like 10:30. Your class starts in 2 minutes, doesn't it? Okay.
Is it server mute? Yes. That's it. I think you guys cannot hear her as well, right? Because I can turn off just for me, but then you're still gonna hear it. All right. So back here, maybe you had this experience in while you were working on your assignment, that maybe you've added a wall to your environment like this one, but if you place the light on the back of it, just like this example, is just perfect. So I have my light on the back of this thing, but the back is totally transparent. That's why the light is coming through from the back of this asset here. It could be an asset from the the market store, the fab store. So how we solve this? Very easy. So in this case here, let's go back to my material in here. This one's called my marble, and here in, oh, that's the texture. My marble material right there. I'll just check here that my material is two-sided. Let me pull it off so we're gonna see in real time. So when I save, you see now it's not happening anymore. Well, it's kind of happening in there, but it's because I have this gap in here. It's not because the material, right? So you can put it here. Yeah, some things are still kind of broken. I'm not gonna lie, I can see there. Yeah, probably because it's too close to the source. But if I go further away, we're gonna see that now we have light in here and no light crossing over. Okay, so this is a very powerful thing to know. Remember, two-sided. And so we have here cast shadows, no cast shadows. Okay, so two-sided. If you're getting light whenever that shouldn't be, it's probably because your material is not two-sided. What else we have here? We have normals. Normals are really, really important if we want to create bump in whatever we have. So if we plug things into normal, sometimes they work, sometimes they don't. In this case, it doesn't. Kind of a little bit. We can see some like 3D going on, but not really. So ideally, normal map looks like this. So let me pull here a texture sample. Let's find a normal that I definitely have here from the starter content. Maybe this one looks nice. Let's open it up. So tiny. No, this one's too flat for us to understand anything. Let me see. I'll just type normal, maybe. There we go. This is an okay example. That's the default normal map of the engine. So if I open up here the texture and we get close, we have this thing here that looks like this. So basically, the green here represents light shining from the top. The purple represents, well, shadows in contrast to the green. And we also have the pink and the light blue. So this map here is creating the illusion of geometry where we have only pixels. Okay, let's let's make it work here. So instead of having this one, I'll use my marble because I know it's pretty flat. Okay, it's flat enough for us here. And now on the marble, oh, it's a nightmare playing with different software, and then you go back and forth and they all have different controls. Get us confused. Okay, so now I'm gonna plug this normal map into this marble here. Let's see how it's going to change. Maybe you can't see really well there, but now we have these volumes that we have here that kind of showing in the marble. Maybe here we can see a little bit better. Okay, we can increase this if we do a multiply node. Can multiply by 5 maybe without breaking it. Yeah, now it looks a little bit more pronounced. I don't know if you guys can see there. Maybe my marble is not the best idea. If I have just a solid color, might be better. Here we have just red. Okay, now, yeah, now we can see better. Okay, so we're not creating real volumes in here, or we're not creating more polygons. We're just tricking the eye of the beholder into seeing that we have more volume where we don't have. Okay, so it's very important using normal maps. They make a lot of difference. For the other ones, I just want to bring your attention to ambient occlusion. This one used to be a big thing. I don't know exactly where we are at with the ambient occlusion, because if you try to use it right now, it's not going to do anything for your material, because ambient occlusion is being calculated by the lumen system that we have in Unreal 5. So I couldn't make it work, but it used to be a thing in the past. Pixel depth offset. Similarly, it's supposed to draw pixels closer or further away from the viewer, depending on a map, like a height map, or a displacement map, actually. But it's also deprecated for now. They said they want to bring back displacement, and they're still working on it because it was a cool thing in Unreal 4. We literally create or will displace or change the location of parts of our material and mesh to match a height map. So it's really cool, but it's not working properly at the moment. But we're gonna do other things. All right. So any questions so far? Let me check the chat here real quick. Oh, a lot of images. Messages. Sorry. All right, solid. Yeah. Okay. Cool. Now let's do some new things. In Photoshop, I'll open a new file, okay? I'm gonna work with small textures in here. So the resolution is still gonna be big, 300 pixels per inch, so we can have a lot of detailing. But the size of my texture is gonna be pretty small, okay? 520, 520, 12, sorry. Is it correct? 512 instead of 520? Yes, I think it is. So for textures, we can, if you don't know, oh, that's your assignment later. If you don't know, here's what I do. So image definition ratio. If you search these keywords, we get or instead of image, let's go for texture. I think that's a better word there. Texture definition ratio, and then when you go in the first link, we should find it here. No, that's not really what I'm looking for. Let's see, images. Probably we're gonna get it bigger. Just because I'm trying to prove my point here, I'm not getting the result that I'm looking for. Damn it! But I'm not on Google. Okay. Um, well, anyway, 1080. Let's see if we find. I want to find the breakdown here. Yeah, kind of. So you guys remember this probably. Well, anywho, we're gonna work with 512 for definition because this is a multiple of 2. In general, if we want to keep our systems performant, we should never ever use other numbers that are not divisible by 2, because in the end your computer is dividing the textures by 2 and transforming them into squares and sampling from those squares. So if you already start with a squared of canvas and you have a low resolution like 520 12 here, it's a low resolution, then things will work fine. Okay, so let's just click here, create. Okay, now we have um, our nice viewport here. So let's start by creating like um, any simple texture. Okay, there are many ways that we can do it. We can, for example, go on the internet and search for free images. So we are on the right side of the copyright wars. Um, Pexels, yeah, we use this one, or Unsplash. So let's find here rock texture. I haven't tested this texture before, so maybe we're not gonna find good things. Let's see. Remembering that we want to make it look seamless, so if I use something like this, it's going to be pretty hard to make it seamless. It's going to require a lot of intervention. Meanwhile, this one might be a little bit better, but I want something like this, just like pure uh, texture. Is there anything else that looks better? This one looks quite interesting. Maybe, oh no, the definition's garbage. Okay, this one's good enough for our training here. Yeah, that's fine. So I just copied, Control V. There we go. I have my texture in here. And maybe you're thinking, hey, Marcel, but this is not good because it's not seamless. Okay, let's see if it's seamless or not. So to do this, let's go to View, Pattern Preview, right there. Okay, yes, okay. All right, again, View, Pattern Preview. So now if we scroll up, we're gonna see, yeah, definitely we can see the tiling in here. Let's adjust it. So the first thing I want you to make, so grab the move tool here, and if you move it around, oh, okay, it's already working. Okay, that's nice. So we can move it around like this to put the seams right on the center of our image, all right? And now from here, let's get closer a little bit, and we're gonna come here to the three dots, and we'll find this tool here, the healing brush tool. We have the spot healing brush tool. I want the healing brush tool. It's the band-aid. And if we hover our mouse here, we're gonna see we have to choose a location as a sample, and now we literally can paint that sample over areas that we don't really like what we see. That's what we're gonna do here. So for example, I will press Alt, and you see my cursor is gonna change, and I'll choose here. This is a good area. Okay, and now you can see now I have that stamp in here. I can come and literally just paint. It's preferable that you do some small brushes, okay, instead of just like painting it all like this all at once. Might look okay in this case, but sometimes it looks horrible. And I also recommend that you keep sampling. So now I'm gonna sample here that's closer to the area that I'm painting, and then you can mix and match them a little bit. So you can see the seam is pretty much going away. Let's do the same thing here. So the secret is try to avoid getting like a repetitive look to things. So I'm literally just trying to complicate. Oh yeah, this one did not look good. So let's try again. Maybe if I sample here on the top, do some clicks here and there. Yeah, that's turning out to be pretty okay. Okay, so we are just confusing the eye, so we don't see the pattern as much. All right, so now if we scroll down once again, yeah, there's still some problems here and there, but we can adjust those, maybe making a bigger brush and painting a little bit more so we can get this pattern kind of spread across. Okay, so work until you are happy with whatever you have. So now I'm just like going crazy, see what happens if I do it. Yeah, it's not too good. Let's go back before. Yeah, it's okay, it's working. Uh, if you find images with the less shadows, then it's going to be easier to get rid of the pattern look. So yeah, I think now we are pretty okay. Okay, we cannot do much better than this. All right, so now that we are happy with our texture, now it's pretty simple. We're gonna do a file. Where is it? Export, quick export to PNG, and I'll make here a new folder. My texture, and now inside texture, so this one is my granite texture. Granite, I will B for base color. Okay, so T for texture underscore granite underscore B for base color. Enter. All right, that's pretty good. So let's see how it's going to look into the engine. How it looks in the engine. So here's my rock face. I will do a right click and ask for a texture sample right there, texture sample. Now, oh yes, we have to import it first. So we have a few options to import um, our content, right? So here inside my materials folder, I can click here import and then go into my computer and grab the image, or I can just open in here and drag and drop, right? You guys remember this. Okay, so now that I'm here inside, or I have my rock material in there, so I'm just gonna plug the base color in there, and I'll change here my texture to my m underscore granite, right? That was the name that I gave. Oh, it's not granite? I was sure. Okay. Let me see again. What's the name I gave it? T granite. Yes, I'm not crazy. T underscore granite. Oh, there we go. Okay, T granite. So here is our beautiful granite piece. So if we just apply it, is it somewhere? Yes, it's on the cube. So it's already working with the cube. Also, let's bring the directional light back. Oh, not the spotlight, the directional light. There you go. I think it was 3 the default. Yes. Okay, so it's nice. Of course, the UVs, they're not perfect because this cube here is not the best, or the UVs are not really working there. So I'm gonna apply to this guy here instead. So let's a rock face there so we can see it better, or even better. I'm gonna bring over another volume or geometry better so we can see it. All right, so it's working, but it's very simple. We just have the base color. So now let's do more experiences in here. What happens if I connect this node here into our roughness map? So remember, black means that we have no roughness and white means that we have rough surfaces. So probably our black dots, they're going to be, yep. So you can see there the black dots, they are reflecting a little bit of light. Meanwhile, the white dots, they're not doing anything. So that's actually pretty accurate to the way that a granite behaves. So I actually like it a lot. So we don't necessarily need a roughness map or any other maps to make things happen, right? Or even so, right now we can see there is a difference between the areas that are black and white in terms of roughness. If I turn this one off, and let's say that right now it's super rough, let's say that's not rough at all, 0.2 is not rough, so we have this polished face here, so everything is pretty much the same, right? In terms of roughness. So if you want to put on a map, then we can of course just work with different areas. All right, um, or even better, let's say that we want to have emissive colors. So I think the best way to do it would be a multiply. Let me test it out. Oops. If I press 3, oops, 3, and click here, I'll get a color. So this is going to be one color that is multiplying with you guys. And you go into rough, oh, sorry, not roughness. You go into opacity mask. But the color I want to see through, let's say, is this bright white. Is it working at all? Oh, not opacity mask, geez. MSIF color and opacity mask is off. And roughness, we're gonna put you there. Well, in this case, I guess it's the opposite. So here we're gonna do an add. Let's see, I never tried this one before. Maybe it's gonna work. No, it doesn't work. Not the way that I intended. All right, that's fine. Forget about it for now. Okay, so roughness, metallic, specular, emissive color. Oh yes, we are missing the normal. Okay, so let's say that we want to add some bump in here. Probably not. I think this is a pretty good material as it is for like a granite slab. But let's say that we want to have some texture in there. What happens if we plug this one into normal? Nothing really. Wow, it looks a little bit weird. The You can see it looks metallic almost. So this is not a good way to do. Okay, so all the nodes they work with grayscale maps. Okay, this is a grayscale map pretty much. Well, in this case it's colored because we are using color, but for the other ones the only thing that they are reading is the amount of black and white that we have, just like in Photoshop masks. So but the only one that doesn't work this way is the normal. So I don't have a normal here and I want to create a normal. Before we creating the normal, let me show you another way that we can create our textures. So this is a second way. I up, updated my Photoshop to show you. So we can do it using generative AI. So let me see here. Do we have it here? I think it's under window. Um, two for sets, timeline swatches, patterns, paragraph, contextual text bar. Okay, yeah, that's the one. Oh, I had it there. Damn. Okay, so this is the easiest way to work with AI. You get your contextual text bar on, and I don't know why it's not showing here. Maybe because I don't have anything selected. Okay, let's see. Let's make a selection. Oh, okay. Yeah, first we need a selection. So generative fill, just click here. Let's see here. Granite seamless texture. Oops, texture. Yes, I agree. Now we're gonna get three options. So if we scroll up, we can see it's pretty seamless, but I don't like the texture. No, it looks horrible. So let's try rock. You can try again the same prompt to see if we get like three other options and if one of those are viable. Yeah, I imagine it was going to give me like rocks like this. Okay, so this is kind of the process. It worked pretty well for me later or before when I use marble. It's pretty good at doing marble, but marble is a little bit harder to do seamless. Yeah, you see, this is a beautiful marble texture right there, and we don't need to, well, change anything really. So you can just export what you have here, and boom, you have this pretty cool texture that's unique to your game. All right, all good so far. Let me see here. Okay, all good so far. So uh, we have here in Unreal Engine, we do have the roughness solved and the color solved. Okay, that's nice. Now let's make our normal map from scratch because this is an image that we just created, right? There was no normal map before. So what we are going to do now, we are going to open um, Substance Design, Designer, Adobe 3D Substance 3D Designer. I think I said 3D twice there. So what is Substance Designer? You know the beautiful textures that we had access to in Substance Painter? Well, they were created by someone in a software, and the software they used is this one. So it's a software used to create amazing materials. If you want to study this software, you can study for years and years. It's a very, very big software. You can do literally any texture like this one. You can do it from scratch in the software. It's really powerful, really cool. I don't know how to use it, okay? Just the very basics, the things that we're gonna do here, and some simple materials, but you can do crazy stuff in here and import in Unreal Engine or any other software, and keep working on these materials inside Unreal Engine as well. As we're gonna learn next week, we can have some art materials, but here we are kind of creating the material. So let's start with a new substance graph. I want an empty project. Okay, the name is going to be my granite. Okay, oh, here's the size as I mentioned before. So they are all multiples of 2 and all multiples of themselves. Okay, so we go from 16 pixels to 4K right there. For this texture, we can work with 2048. That's a pretty good number for like any texture that you're not using for film. If you're using for film, then we have to go with 4K. Okay, but this one is twice a good HD, right? So it's the 2K here. For games, to building the things, it's good to work 2048, but for running the game, the maximum we're gonna go for the majority of assets is going to be 1024 or even 512. That's why we chose 512 before. But for this one, let's work with um, a bigger asset, okay? Just for fun. So yeah, I need it empty, 2048, my granite. Yeah, okay. There you go. So I'm not gonna explain the interface really deeply, but bar here for the basic things: file, edit, tools, windows. Here we can save project. Here we have the explorer. So here we have the project itself. Okay, so right now it's in a save package, we don't have it saved anywhere. And here is the material itself that we are creating, the flow here that we're gonna make. So my granite, it's very similar to the way we have in Unreal Engine, the materials in here. Okay, it's, you can think as the same area, this area here. So that's the viewport where we can input a lot of things in here, and also we can press space to add things. Here is the preview of the material that we are creating. Here's the 2D preview, and here we have parameters that we can play around. Okay, so in a nutshell, that's the interface. But here we're gonna do something very, very simple. First, let's add a base material. Okay, so um, details panel. Now I don't remember. Jeez. As you can see, I don't work this one. Oh, okay, we can do with a bitmap from file. Yes. Okay, so uh, there are some ways that we can do here. Let's do this one. So right click, add node, add bitmap. And here we're gonna choose from file. And now from file, you're gonna go whatever you saved your texture. In my case here, my granite, and okay. And I have two options: link to source, link resource, and import resource. If I link resource, whatever changes I make to that image that I'm using as the bitmap is gonna be in real time, is gonna change in here. If I import resource, I'm just importing a new or a picture of that thing, and that's what we're looking for. We're not going to do a lot of work back and forth, so just import. So now we have the bitmap. If you press the mouse wheel, you can pan around. Okay, so here we have the bitmap. That's the original image. We also gonna need a normal. So a normal, it's right here. So just click on this button and you're gonna get a normal, or you can right click, add node, and find normal in here. Or you can just press spacebar and now you can type normal and it works as well. Okay, So what else we have to add here? Also, let's press spacebar, and here we're gonna add a base material right there, base material. And you see this base material looks a lot like our material in Unreal Engine. So this is the output node, just like we have here in Unreal Engine, the output node, okay? And base color, metallic, specular, blah, blah, blah. If we look here, we have base color, normal, roughness, metallic, height, and ambient occlusion, the main ones, okay? Um, okay, let's start with the base material in here. So this is the output, but not really the output. We still have to create the outputs. If you see here, no output node defined, meaning that we cannot export whatever we create in here. We cannot export. So let's create those things first. Base color we don't need because we're gonna use um, the same bitmap that we have here. Okay, so that's all right. So it's not going to change from the one that we have in Unreal Engine, so we don't need to export. But normal, we do have to, we do need to export. So you can click, drag, or click and click again, or click and drag. And here we're going to choose an output node. Okay, output for normal, and that's actually the only output we're going to bring out of here. Um, that's pretty much it in that end. So now you're going to see here your base material. We have outputs, but we don't have any inputs because we have to come down here. So select the base material, scroll down, and similarly to what we had in Substance Painter, now we can say, okay, give me normal and give me base color. So I can plug these guys in. So now I'm just gonna plug base color in there and plug normal. Okay, and now if you right click, drag and drop, you can see the material applied here to the preview. It looks very metallic because our metal number is probably 1 in here. So one way we can correct that, we can turn on metallic here, and now it's 0. So it's no metallic. It's nice. Okay, now let's create our normal. It's kind of easy because I have a grayscale image, but even if it's not grayscale, we can literally just plug in here, and well, not that simple actually. So you see here is red because it's not working, so I'm gonna select and delete. What's going on here? If you put your mouse over, you're gonna see that saying, hey, I need like a number value. I don't need a bitmap value. Let's see if it's gonna pop. Should pop. Well, I don't know, it's not showing, but yeah, it's going to be to say, hey, I can't use this input here because, oh, there you go, image input grayscale. So we needed the grayscale, not a bitmap. So something that we have to do here before plugging the image, we have to convert this image into a grayscale. So we're gonna drag from here and search for with a grayscale conversion. All right, so we're going from the yellow node to the gray node. And now you can see it's the same thing, but now only grayscale. Now I can plug this one in here. So if we see right away, maybe we can see some texture popping in here. Can you see that the dark dots here, they're a little bit like pushed into the block? Maybe we want to improve the depression in there. So select your normal, and here we can change the intensity from 1. We can go, I don't know, all the way up to 3. And now it's more gritty. It's easier to see the texture. Here, it's pretty good, the light below here for us to see it. Okay, so now we have this normal map that we didn't have before. Maybe you want to go back to 0. Now it's flat again, just so you can compare. Look the light, how it's going to change as I move here. So pay attention there. Let's change the intensity, and yep, it's a big difference, right? So yeah, that's how we can generate normal maps. Maybe instead of having the dark spots, the darker areas, you want the light spots to be what is pushed into the depressions in your material. So what we can do here, we can do oh no, I don't remember. Is it flip? No, it's not flip. Is um, geez, let's find here. We can invert, maybe. Yeah, invert grayscale. So now we have the opposite, right? So everything that's was white now is dark. So if we plug in here, we're going to see the opposite effect. So now the white is pushed in and we are keeping the blacks up. That's actually how it usually is, because the dark spots, they're usually harder than the granite around it, or the arenite, or whatever it's made out of, sand usually. So it's gonna get um, well, we're gonna keep the dark ones and just destroy the other ones. So I like this one. I'm gonna keep it as it is right now. Maybe 2 is a little bit too rough. I want to use 1 here. And the same thing works for all the other nodes, okay? So you can do crazy things in here. And yeah, let's say that we are happy and I want to export. Okay, I just want to export the normal map. So now that we have an output in here, okay, it's important, otherwise we're going to see an error here, like a yellow triangle there, and here a text saying that we don't have an output. So, but since we have the output here, I believe I can right click and do it from here. No, probably not. So let's click here on my granite and export outputs right there. Okay, um, so here's where you're saving it, the destination. You can click here on the 3 dots and placed on the right position. So here's going to be texture underscore granite underscore, this one is the normal, so n. Okay, select folder. Oh geez, okay, no, this one's just the folder, not the name. Damn it. Go back there, that's my textures folder. Good. Format, yes, pattern, I think that's it. So export outputs, and that's it, it's done. So now if we go here, you can see my granite output. If we change the name here, just to keep our nice nomenclature going on. So 3 T for texture, granite underscore N for normal. Now I can just bring this guy over to Unreal Engine. So if I have this one open, I can just drag and drop my normal back in here. Ta-da, it's there. So now if I need to, oops, not to, no, don't save. Where is my material here? Okay, my rock face. Let's leave it like this so we can see in real time the changes. So here, if I want to change it or add it, I will do a right click, texture sample, right there. I'll plug this one into the normal. Where is normal? Right there, normal. And oh, do I have the right texture already? Yeah, probably because I had it selected. It's already there. So when I save, we're gonna see the difference in here. You see, now we have this texture going on, and also the roughness is there. Is it there in the roughness? Yes, it is. Okay, so here is our new material from scratch. Again, we only need base color, metallic, we need to know if it's 0 or 1 only, roughness, and normal map. That's it, all that we need. Okay, but that's a simple material. Now let's make an animated material. This one ought to be pretty cool. Okay, any questions so far? Let me see here. Easy or hard? Let's do another poll. So easy and hard. So this materials. We'll see later. Okay, so that's for basic material. Now we're not going to need this one anymore actually for this class. Let me show you, since we are already here, I want to show you things that we could do with it. So substance designer, just so you can get an idea of how interesting is this. Oh, okay, this is the tutorial,
Since everything in design
the base tutorial that Adobe teaches us how to do things. So uh, in the end, we can have materials like this one, as we can do in Unreal Engine, but it's a little bit different. This one's focused only in material. There we can have animations and other stuff. Um, but anyhow, so using masks like this one and changing parameters, we literally can create any texture of anything. In this example here, the yarn texture that you see, this pattern here, is being created to create this beautiful. I saw it in the thumbnail. Where is it? But it's a beautiful textile. I've been playing Zelda again. Anyhow, so it's a very powerful tool. I think you should look into it eventually. And if you're planning into working with textures for games, animations, or film, it's really, really interesting. You don't need Photoshop anymore. I'm just using the clutches here because it's easier for us. But in a more professional level, you really want to learn this tool here. And it's quite new as well. So there are not a lot of specialists out there. Okay, back to Unreal Engine. So I'm just gonna close this one. You can save yours if you want. I don't want to save mine. Okay, so now let's do an animated material. So I'll do a right click here, material, create a new material, m underscore animated material or animated. Let's start with arrows. You've probably seen those before in like uh, racing games, probably. So now let's open it up. What I want to make an arrow, like a simple arrow that moves from left to right, and that's it, okay? But I'm gonna put it on my material. So here, once again, Photoshop. I don't actually need this view anymore, but I'm gonna leave it as it is. Let's make a new layer. Oops, I want my regular lasso tool. I'm just gonna make here a simple arrow, okay? Like so. Okay, that's my arrow. I'll be very, I'll make this cool arrow that's, I don't know, green and blue. Maybe a sonic arrow or something like this, all right? I can even, I don't know, give it some opacity if I want to. And turn off the background, of course. Okay, or no, you know what? I'm just gonna leave it as it is, 100%. I don't want opacity. All right, so now from here, file, export as PNG, texture underscore arrow underscore base color. Okay, now in Unreal Engine, I want to import this thing. So I'm just going to come here, arrow B, okay, open, import. I have it there. All right. Animated arrows. Let's start with the texture. Okay, texture sample right there. For this one, I want my T underscore arrow. Boom. Putting there RGB. Yeah, that looks good. Let's start in here. Okay, I'm gonna use the plane once again. Okay, so I want this arrow moving from left to right. How can I do this? It's actually pretty simple. There is this panner. Okay, so right click and search for panner. Here we have the panner coordinate. So for coordinate, we're gonna click here. Okay, connect these two. And now for things to move around, we literally just have to change here the speed for X and Y. So X is in this direction. So if I put here, let's say 1, oh, it's moving backwards. Okay, -1. Okay, it's moving the direction that I want it to go. Perfect. So I also don't want to see the white around it. So I can probably just change here from my opaque to masked. Okay, and I'll connect my alpha into my opacity mask. So we're gonna have only the arrow floating. And I'll also connect my RGB to emissive color to make it bright. Let's see. Yeah, it's kind of working. Not really great, but it's working. So let me do here, maybe a multiply would be good. Let's see if it can look better with a higher number. Yeah, in the end, it's going to look white because it's emitting light. So maybe a little bit less. Yeah, that should be okay. Or if we really want to be creative here, I don't know if creative is the right word, but anyhow, so I'll make here a selection. Sample all layers here. So I'm gonna make a new layer, make a selection, Ctrl Shift I to invert selection. And now, you know what? I'm just gonna subtract from this selection. Oh, cool. I had a better idea. I was going to do the surround here. No, Control D or Control Z. So I'm just gonna unselect the other areas and keep just the back of my arrow on my selection. So now I can, oh geez, this guy is like a, let's rasterize layer. Okay, no, it's not rasterized. Flatten image. Oh no, not flatten image. Geez, I just want to get rid of this thing. Let me see the best way. Convert to smart object. No. Damn it. Where is it? Blending options. Disable layer mask. Yeah, I just want to convert the layer mask. This whole thing into its own layer. Create looping mask. Mask to all objects. Damn it. Oh, anyway, I'm gonna do it again because it's probably gonna be easier.
Mm-hmm. You could use the mask as a selection and then
Oh, good.
just delete everything. Yeah.
Good. Okay, yeah, that's a good idea. Um, if I use the
I
mask,
think right click on it
right click,
and
let's see,
then
select.
add mask to selection or
Oh, there
subtract
you
it.
go. Good. Yeah, thank you.
Might have to
Uh,
invert it.
oh, let's do this. And now, oh yeah, we had to invert it first. Damn it. I'm overcomplicating things. So I'm just gonna do it simple here because my gradient um, is not set up. So I have this new layer instead of our good old gradient that we love. So I'm just gonna change here for the gradient. Can I change it here? Yeah, I want the classic gradient. So much better. And now I'm just gonna paint here. Okay, that's nice. So I'm just gonna export this thing now. Export as PNG. So this is my T underscore arrow back or arrow, yeah, back. Let's go back. And this one's going to be my emissive. So we can have two things. Let's just make it really flashy. Okay, import, emissive, there we go. Now back here. Here we can do the texture. Thanks, Matthew, for your support. So here, T underscore arrow, oops, underscore arrow, back emissive, nice. So I'm gonna plug this one into the emissive color. Let's see if it's gonna work. It should work. Yeah, it kind of work. So here I'm for the opacity mask. I'm also gonna do. Yeah. Can I combine opacity or alpha? Blend difference maybe. Let me see here. Yeah. Well, anyhow, I was trying to make just the back more illuminated, but since we are using some alpha, it's gonna take extra steps, and I don't want to spend time troubleshooting because I'm adding here the white on white because the alpha is going to turn white anyway. If we just do a multiply, what happens here? Yeah, as I imagine. Okay, never mind. Let's keep it simple like this. And I'll plug this one into the mask, and also I want to put this one into MSIF color so we can see it. That's fine. Well, that's pretty much it actually that we need to our animated arrows. If we come back here, I'll select this one. So once I add a geometry, it's gonna come with it. So I know, let's try a cylinder. It's going to look interesting. Okay, so there you go. Now if you have a car game, you can point the direction. What other things that we can do here? I made a list of cool things that we can do. We can do a matrix, like like the letters falling down in matrix. We get a text and we organize it to be vertical. Where is it? Vertical here. Yeah, there we go. So yeah, lowering epsilon whatever works pretty well. Oh no. Ah, what am I doing? I have sausage finger syndrome today, clicking everywhere. All right, so this is one. Let's make it kind of distant from the other one, and let's change it a little bit like this. And so that's one image. File. Um, Geez. Export here. Oh, okay. So that's T underscore matrix 1 underscore base. And now let's do the same thing for the second one. Just gonna put them here and bring them down like this. And I'll turn off those two, and you're going to be, it's not going to be perfect, as you can see. I'm just doing it very, very quickly, but so you can get the idea. That's two, save. So if we go back here, let's make yet another material. So that's going to be material underscore matrix. So here we need a panner. We're also going to need a texture sample. Connect those two. RGB. So for you, we need a matrix 1. T underscore matrix. Z. Oh, I haven't imported. Damn it. Okay, matrix 1 and 2. Yes. Okay, now we come here in or T underscore matrix. Am I getting crazy? Why is not here? T. Oh, matrix. Okay, I said sausage finger. T made. There you go, matrix 1. I think it's gonna work, guys. I haven't tested with 2 before. 1 and 2. We plug them both. You're probably gonna get a similar issue with the alphas, but let's see. So here we want a panel. I want you both multiplying to get here. And actually, if we have two panners, it's going to be better. So we can have this one in, I don't know, 2 speed, and this one we can have in, I don't know, 0.5 to go way slower. Okay, can you see how it's working? Pretty cool. Maybe 2 is too much. Let's do 1. Oh, not 10, 1. There you go. Now that's better. Or maybe this one's -1. So one's going up, the other one's going down. And we can plug those both into an opacity mask here. Let's see if it's gonna work. Oh, it's literally the opposite that we need here. Okay, so let's do an add. Add is the opposite of multiplying. Let's see if it's gonna work. No, it didn't. Oh, the alphas. Yeah, okay. Let's multiply the alphas. Yay, because everything's moving. Yeah, I don't think it's gonna work for this specific one here. That's sad. If we invert the colors, then it should work. Let me see. Okay. Okay, that's not too bad. It's only one side working. Because the other opacity mask is going down. Yeah, there's a note here. I don't know which one. Maybe subtract from. I don't know. Have to study this one. Oh, there you go. It's an add, but it's now it's working. I don't know why it didn't work last time. So let's see in our new geometry here. Let's grab a box and let's add the material to it. Matrix material. Yay! Now we have a matrix material. We can also do some other things, for example, some water. Oh, and something here that's annoying me, you see that we are casting shadows. We can also click here and we can say don't cast shadows, and here unlit, or maybe lit's better. I think that's it for not casting shadows. I'm almost sure. Let's see if still casting shadow. No, it is. So we have to find here shadows. Na, na, na. Well, in this case, probably it's easier if we select this guy here, the volume, and here we turn off the cast shadows. Yeah, things are not helping me today. But that's fine. All right. Oops. So that's another example. We can also work with water. I already built yesterday or 2 days ago the base for this. It's not a beautiful water, but let's see here. Oh, I think I can show you the material that I built. It's easier. Content here. So I have my animated water. Where is it here? So if we change, so you can have, for example, rocks with a slight animation of water coming from behind, as you can see here. The way I've accomplished that. So for the texture sample, you could have anything, right? It could be, I know I chose this image here, but it could be our marble that we, or not marble, we worked with granite today. Okay, so this is my granite.
I have a random question.
Yes.
So would you be able to only apply, because I've been wondering this since the arrows, but are you able to apply it to only one side of an object?
Only
Like,
if it's a geometry. So for example, this is a geometry, so I can slap materials individually into different faces. As you can see, it's
ooh,
a
all
static
right, because
mesh.
I was curious, given the fact that say we're making a game and I'm looking at the arrows, like, okay, that if you wanted to make a Mario Kart, like for example, you wouldn't want to have arrows floating everywhere. You'd need something to hide all the other sides as well.
Oh yeah, but in this case, you could use instead of a form like we have here, you could use, let me see here, a shape, a plane.
Oh, perfect. Thank
So
you.
yeah, the plane, the back of the plane is invisible, but the front is not. So you just slap whatever material you want in there, and it should work. Uh,
Awesome. Thank you.
you're welcome. So this animated water function here, I would just, can I break it and put in here? Collapse nodes. Well, anyway. Oh, collapse function. Oh, anyhow. So the two pins that are coming out of they were all in the same material. It just made it into a function to test something. So here we have the panner, the two panners with different speeds. Um, Here we can probably see a little bit better. My texture, you can see it's a very simple texture. You see, it doesn't really look like water, but I'm using this water here on the specular and roughness. So that's why it looks moisty, because I'm animating this white texture here, these white waves, and plugging into the two panners. I'm adding them together and adding them to the multiply, or to the roughness, and to the specular. Okay, so that's how you can make some like watery materials. Let me see, we still have a few things to cover, so I'm gonna go a little bit faster. Okay, so that's for animated materials. We can do a bunch of things with this, you can imagine. So it's very simple, it's very performant. You may be asking yourself, oh, how bad is this on the computer? It's very simple, very performant, because we're not redrawing the same thing over and over again. We just have one drawing and we are running it. That's it. So that's why it should, we don't have a lot of draw calls. We are only calling this texture, this tiny texture, 512 once, and we are rendering it in a different position. So it's very, very performant. Let me close all of these. And also, if we dim the lights once again, you see our arrows are pretty cool. Okay, my next trick here, if you don't have any questions, will be, um, let's work with displacement of materials. All right, so we're gonna turn something like this, like a flat surface. We're gonna make it into this, into, or a material surface that it doesn't have any bumps other than normal. We're gonna turn into this, okay, something, or a 3D mesh that has bumps, and yeah, works pretty cool. So a few things we need here to make this thing happen. So maybe you can go back and use the Substance Designer later to figure this one out, or we can do it in Photoshop. So let me get back here to our granite. And let's say that for my granite, it's not just like the plain granite. I actually want to make a dent in it. So a circular dent. So I'm going to make here a circle, right click, stroke. I want to stroke in black, or well, let's do black, in black, and I want it to be maybe 10 pixels wide. Okay, yeah, that's enough. That's good for our example. Control D to deselect. Now I'm going to do the same thing. I'm going to do another circle here with, or maybe a square. Let's do it differently. And right click, stroke path, yeah, stroke, 10 pixels. Maybe I'm gonna do this 120 to make it bigger, but this one I'm gonna make it white. Okay, totally white. Okay, there you go. So that's what I want to design to show you how this thing works. Okay, so now with or without the background, I'm gonna do with the background. I'm gonna export this one. So we're gonna see it's gonna look interesting. So quick export as PNG. So this one's going to be my granite instead of normal. This one's going to be my granite height. So H for height. Okay, now back to the engine. My materials. Let's import granite H. Okay, and it's there. Okay, cool. But I think first, let me just read here my notes. Make a texture. Yeah, let's create a material. Okay, a new material. So I'm gonna create a new material. Right click material, m underscore. I'll call this one new granite. Okay, just because I will demonstrate in this one. New granite. Open it up. This one I'm just gonna use the base color. So that's going to be a texture sample. My granite. Okay, I just need the base color for this one. Okay, save. I'm just gonna put it in here so you can see how it's different from the other one. Okay, so now what we're going to do, we're going to change modes. All right, so I'll go from the selection mode, we're going to go to the modeling mode. Now here on the modeling mode, we are going to create something. We're going to create a rectangle. It's right there. Okay, you can just create a rectangle anywhere you can see it. You can make it bigger. Let's do 200 by 200, so 2 meters by 2 meters, just to have an open, a size similar to that one. I think this one's 2 by 2. And that's it. So we're gonna click here to accept. Boom, now we have this rectangle here, this plane. So now we're going to scroll back to oh geez, here. Okay, add a rectangle plane. So go to mesh options. I think it's in here. Yes, here, mesh options. No, it's not here. Model, subdivide. Is that the one? No, remesh. I want to remesh. I think it's here. Remesh, right there. Okay, so under mesh options, we have here this button remesh. That's a triangle with a plus sign. We're gonna click here remesh. And right now for this plane, we can even see if we get a little bit closer, we have 5,000 triangles for this plane here. I want something with a lot of detail, so I'm going to multiply this one by 4. Okay, so now we have 20,000 triangles only in this shape here. The bigger the number, better the definition. Okay, so I'm just going to click here accept. Okay, cool. So now from here we're gonna go to the deform menu that I think is this one. No, this one, deform, right there. And now we're gonna choose here displacement. Okay, displace. Okay, so you can see here it's already getting displaced, but here we just have a noise map that's displacing everywhere. Okay, so instead of using the purling noise here, we're gonna choose here a texture 2D map. And now we have to say which texture we want to use to bend this one. So I'm going to use the texture that we created for this. So my granite. Okay, and the granite height here. So now you can clearly see that whatever areas I have with white, it means that's something that's close to us. So that's why it's here on the top. Everything that I have with black, that's the lowest part of our texture here. Okay, it's like a height map for the landscape. Same thing, same idea. And everything else, those are the black dots and the all the different things that we see in the original material. So maybe it's a little bit too strong. Can we lower this one? Now it's here the strength. I don't think so. Sorry. This one's not looking as good as the other one over there. But let's try again. Granite. Um, where I can change the scale here. Oh, here, intensity is right there. So instead of 10, let's try 1 instead. Yeah, you can see it looks a little bit better or closer to what I was hoping to get. And now if we say accept, now we have this, and let's add our material in here. Okay, so now our displacement matches our material. So we literally have, if we look from below, probably it's going to be easier to see, or without material. Let's go back without material. So now we have these extra polygons in here. Of course, for this example here, it doesn't look great because it's just granite. It doesn't have like a real texture in here. But you can do things like this. So let me show you the texture that I used to create this one. So my base texture is right here under content. So this is the texture. Okay, is my marble texture with some black stripes. So as we've just learned, black means that it's pushing back our mesh. So that's how I achieved this cool um, effect here, the same way as we are working with the black and white in this other texture in here. Okay, and you can see here nothing changed. We still have the same plain image here for the base material, but here for the material applied on this mesh here, then we have another thing. If we just add another material here, let's say the marble material, we're still gonna keep the geometry, right? Although we have this new material. So that's one way that you can create geometry out of textures. If you go, now it's not so easy anymore, but we used to have easy access to the Quixel Bridge textures. No, cancel. Yeah, I know. Let's visit the fab. So here, let's say we want to find rocks and we want to the assets and rock texture maybe. We're gonna find, yeah, something like this. Well, those are bricks, not technically what I want to show you. But let's say that you have pebbles or rock faces like this one, and you want to bring this beautiful height map that we have here, you want to bring it over to your material. That's something that you can do. These materials, I'm sure they have height maps already, so you don't have, you just plugging the height map onto, geez, so many tabs here. Okay, onto the displacement in here, and you're gonna be good, right? Or if you want to build it from scratch, remember white means that's closer to us, dark means that's further away from us. So you can have the image in here and literally make a new layer and start painting. Okay, I want all the golden parts to be closer to us, so you start painting it properly, not like I'm doing here, to bring it forth. Or maybe you want to make here like a rock face or like a tile thing, and so you literally hand paint with like proper care and then you can make these textures or these height maps model whatever you have in here. Okay, so the final thing we're going to cover today inside Unreal Engine is displacement materials. All right, so let's make something similar to this blood that I have in here. So let's go back to Photoshop first. I think I'm gonna do blood because it's probably the simplest one to demonstrate, and we usually gonna need blood for our games. So go and search for a brush that works for you. I'm using this one, the Kyle Bonus Chunky Charcoal, because I think every time that I click, I have kind of a splatter. Maybe that's the one that I'm using. Maybe I'm using something else, but it doesn't really matter what you're using. Yeah, that's a wet brush. That's why it's kind of weird. We need some color first to paint with the wet brushes. But whatever brush you use doesn't really matter. What matters is that you're happy with what you're creating. So I'm just going to choose here red color, a dark red. Maybe this one's a little bit too bright, a little bit darker. It's more veiny. Um, whatever brush you want to use, okay, works for you. Whatever size, and start splattering blood. um, I don't think that's a good brush because it's very round, so it looks round. That's why this one's kind of okay. Pastel ones, because they're not so, yeah, that's better actually, way better. Okay, so just splatter some blood here and there. You can use any technique. You can search for how to make realistic blood, but we only need the base color here. Okay, so let's say this is exactly what you're looking for. You're very happy with this. It could be oil splatter, for example, if we just turn this one black. So now let's export PNG T underscore blood, B for base. Now back to our engine. Let's import first inside my materials. Now let's import our blood. Okay, there it is. Now I can create a new material. So n underscore blood decal. Okay, it's important to say that's a decal because we're gonna make a decal now. Open it up. Here we are. First thing, we're gonna change here the material domain from surface to defer decal. Okay, you can see that things are kind of all broken. But we're gonna change here the blend mode from opaque to translucent. Okay, and now we have these pins here open for us. So we're gonna do here a texture sample. This texture sample, you probably guess it, it's going to be our blood, B, right there. That's the second blood I created in this project. I'll place this one in base color. As you can see, it's kind of already working. I need to put on my alpha into the opacity. So now we get even better. And finally, my roughness, since it's blood, I'll put my roughness 0 so we can get the nice shiny, like watery. And the specular, I think, should be 0 or maybe 1. It's probably 1. So let's see in scene. That's it. That's all we need to make a decal. We just need the image and to set it up as a defer decal and translucent. So now when we get back to the project, I can drag and drop my blood decal over there. And hey, Marcel is looking super weird. What's going on? It's because the direction of your decal is kind of broken. So this one will work really nice if we put it on the ground, as you can see here. Okay, and do I get any light? This one's getting a lot of light. This one not yet. I'll check what's going on. So this, if you want to put on the wall, you just rotate it 90 degrees right there, and now you can place it on the wall. Okay, and you can scale it down And well, that's pretty much it for decals. It's pretty simple, but very, very, very useful. Let me see why this one I'm getting some light reflections and the other one I'm not. Opacity. Oh, my roughness is the red channel. Okay, I'm very smart sometimes and I forget how smart I was and get dumb again. Okay, so let's get back here to my blood decal. So instead of roughness being 0, I'm going to use the red channel to check whatever is my roughness. So everything that's red is going to be very not rough in this case here. So now we should get a better result. Let's make a copy. So if you press Alt and move it out of place, we're going to make a perfect copy of it. And notice that we have an arrow here pointing downwards. That's the direction of the decal, okay? There you go. Now we have light reflections. Yay! The other one's superior, but this one's okay. Maybe I have to do the same thing for the specular. That's my blood decal. And I want to open, oh yes, my blood decal, specular. Maybe let's try this one and see how it looks. It's a lot of try and error here, by the way, guys, if you haven't noticed. Yeah, maybe I don't need a specular at all, or just like leave it as 0.5. Let's try 0 and see how it looks. Yeah, that's no reflections whatsoever, so 0.5 may be the best. Yeah, it's much better now. Still kind of looks worse than this one. Damn it. I'm very curious why it is. I think they are set up exactly the same. Yeah, they are exactly the same. Probably the color, it's doing more favor, a darker color, because they are literally the same thing. Yep, they're literally the same thing. Well, all right. Any questions about decals? Let me see here. Yeah, everything's pretty easy so far. Good. All right, all right. So now we're finished with Unreal Engine. Let me just double check here my cheat sheet. So, once again, let's do one more example for the decal. I just showed you how to do blood, but let's say, I don't know, I like Tesla, so let's find the Tesla, or even better, let's stay in-house. So Soka UFV, where's the logo? Damn it, I just want the logo. Okay, let's do UFV logo. Wow, so hard, but there you go. We have one here. So let's save this image. This is going to be my T UFV underscore base color. Now, let's say you want to have maybe a wanted poster on your wall. The best way to do it is using decals. So let's create a UFV decal. Or you have signs like a stop sign, that could be a decal as well. So here inside my materials, I'm going to import the UFV1 logo. Now let's make a new material, m underscore UFV decal. Now inside here, we'll do a 2D texture or texture sample, UFV. There it is. You go there. In this case, we don't need alpha because the whole image is it's here, right? We don't have any alphas. So let's change this one to decal and translucent. Save. Now, let's say you need to place UFV on the wall or Coca-Cola or whatever is your project. Sign demanding. There you go. Very easy, right? And when we play, we can't tell those are decals. They look pretty good. Of course they don't. Oh, okay. That's funny. Why just the UFE is working and not the other ones? Oh, that's really funny. Okay, because this one's very close to the wall. There's a way that we can ignore the pawn. Hmm. Two-sided, cast shadow, blah blah, events maybe. Well, I have to check this one later and bring back to you the information. Because, well, that's not ideal, right? We should ignore our pawn at least. Yeah, I'll have to check later. I don't know, but easy to solve this issue. Just push it closer into the wall like this, or maybe even it's make it smaller, and now you can put it there perfectly. And now let's do it once again. Yep, it's not broken anymore. Yay! Okay. And here are the things that we created. They all work in real time and pretty good. All right. I hope it.
Just
Oh yes, go on, Matthew.
just did a quick Google. Um, there should be a setting in the objects to like turn on whether decals can apply to them.
Oh, okay, on the objects. All right, that makes sense. We should have one on decals as well to make life simpler. But yeah, okay. Um, all right, all right. So I hope these new techniques help you to achieve better looking results in your 3D environments and give you a better breadth of things that we can do with materials. Next week, we're gonna program materials for real. These materials, they're very, very simple. They're like a couple boxes, and we're gonna have some math in there and literally programming the materials to behave in a certain way. So stay tuned for next week. But before that, if we are all good with materials, um, I want to go over the level design stuff that we still have to see. Today's a very long class. Okay, let me know if you have any questions. Okay, I'm gonna open here our open world level design.
So, are we getting assigned assignment 2 today?
Yes, we will.
And
Or
that's
do it.
not due until when? After reading break?
I don't know exactly now, but I think you have a couple weeks to work on it.
All right.
Yeah. So I think good thing to do is just to explain what is your assignment so you know what you have to focus. In a nutshell, we're gonna read later step by step, but in a nutshell, we're gonna make the documentation or the design of our open world island. Okay, that's it. So here you're gonna have to deliver the level design pillars, level design vision, level design references, visual references, bubble diagram, and level design layout. We're gonna need a main quest, a secondary quest, blah blah blah. But that's it. Okay, so you'll be tasked into creating the documentation for your open level island. And meanwhile, while you are developing the documentation, we're gonna be learning more techniques in a real engine to change your landscape and to apply materials to the landscape. So once you have your design, you just have to model your island, and many things will be already there for you because we've learned the tools, so it's easy to build. Okay, so we're gonna be seeing things in class that are 100% Unreal Engine, but those techniques we're learning, they're going to be used to create your island. So the faster you can come up with a design for your island, you can start making this design in your 3D environment in your Unreal Engine and just saving time because you're not going to have to remodel it later to fit your design. So just to think about it. But if you don't have a design figured out in maybe 1 or 2 weeks, at least the main lines of your island, how it's going to look like, uh, well, no problem. You're just gonna have more work later in your Unreal Engine to adapt whatever you've been practicing to the actual level that you're making. So yeah, no Unreal related submission for assignment number 2, but it's a documentation. So let's learn about how to design this documentation and how to think about open worlds. Uh, just to kickstart, uh, although I'm gonna evaluate your level design as a whole for the island, I'm not really thinking in terms of game designers, or how really good is your design is helping the player on their path, or I'm not going to be very meticulous in my analysis because you guys are not trained in level design, like properly trained in level design or game design as a whole. We are focusing more on the visual aspect of Unreal Engine, or the technical aspect, I should say, in Unreal Engine rather than the game design aspect. That's something that we actually don't need an engine to perform or to learn. We can just learn using Excel spreadsheets pretty much. Um, so just to say that I'm more concerned about the visuals for this assignment than the actual gameplay. Okay, but and also open world is probably the hardest level design archetype that there is out there to develop, because well, it's open. But we're gonna see here what are the issues or the challenges with open world. um, so and we haven't even practiced 2D level design or just like a basic level design. We just had a little bit of practice in MEDA 280, so don't be too stressed about the level design itself. I'm more concerned about the visuals and the artistic side and technical side for those assignments. Okay, just to clear this one out of the way. You're not supposed to make an open world game from scratch. That's too much, especially for a single developer. Okay, so first of all, what are open worlds? Um, we have the the classical gameplay, that is the linear gameplay. Okay, now it came to my mind. I was fishing for it for the word. So it's called linear design when you have a level that has a beginning, a middle, and an end, just like a narrative, right? You start in the beginning, like Mario. Think about Mario, good example, or Sonic, but Mario is even better because you cannot go back. So Mario 2D, you start in the left corner of the level, and as you progress you cannot go back, and there is only one way forward, okay, or in this case to the right. That's in 2D, but if you think in 3D, so many other games like well, I'm playing Space Marine 2. It's a very linear game. You have a clear beginning of the world, so the levels, they're kind of tunnels, or they're rooms connected by hallways, and in the end you're gonna have maybe a boss fight in the final room. So it's a very linear experience. Maybe there are two different lines that you can choose from to approach, maybe so you can have multiple times the player replaying your game. One time they're gonna take uh, path A, the other time they're gonna take path B, but it's still very linear. Like, you don't have many options or infinite options. Meanwhile, in open world is the opposite. It's a world that exists and it's totally approachable from any direction. So you don't have a lot of control over the player. In linear gameplay, we have a lot of control over the player because, well, the player is gonna take, if they're running from the beginning of the hallway until the end of the hallway, you know how long it's gonna take to go from one room to another room. So we have a lot of control, right? We literally are directing the player every step on the way. Meanwhile, in open world, we just create the world and let the players explore. So it's extra hard. Let's read here what's written. So in open world level design, we are not creating the level experience itself, as I mentioned before, like a music that we, or narrative that we have beginning, middle, and end, but we are creating a playground to let the players experience and discover what they can do. Here, I think it's important to make a disclaimer between, or to show, highlight the difference between open world and sandbox games. Maybe you heard those names before. So GTA is a game that's at the same time an open world game and it's also sandboxy. Meanwhile, I don't think The
Like
Witcher,
Minecraft, for example, would you say?
like
Would you?
Minecraft, yeah, Minecraft is a good sandbox open world example as well. And for example, The Witcher 3, as we see here on the screen, I wouldn't say it's sandbox at all. So, what is the difference between open world and sandbox? Open world, as I mentioned before, is when there are no boundaries on the world, or it looks like it's a seamless experience, and you can explore anywhere at any time and approach the problems from your own perspective. Meanwhile, in sandboxy games, but you have a clear objective in open world. For example, in The Witcher, you are a Witcher and you're trying to kill the monsters to get some loot to improve your abilities and move forward in the narrative, rescuing Ciri and so on. But in a sandboxy environment, there are no clear rules or objectives. Okay, that's why although in GTA we have clear objectives for the narrative to finish the game, but when you're exploring the city, you can kind of do anything, just like in The Witcher. But there is something else in there that we don't see, for example, in Red Dead Redemption, that is from the same developer as GTA. Uh, the game gives you hints of things that you can do. For example, in GTA, if you see a ramp, you're probably going to try to jump out of the ramp to get some points and see where you're going to land. Um, the players, they are trying to, you create a sandbox with a lot of moving elements that players can explore and create their own emergent ways to play. Meanwhile, if you have just an open world game with set rules, there is no players will not create new ways to play. They will maybe find new ways to kill an enemy, but in the end, the game is about killing enemies. Doesn't make sense what I'm saying?
Yeah.
Yes.
Yes. Okay. Good. Good. It's hard to know without seeing your faces. Okay. If it doesn't make sense, let me know. I can explain again. So sandboxy, like in Minecraft, you're free to explore and create your own fun, but in open world games, not necessarily. Maybe you have a more specific way to achieve fun, or an expected way to achieve fun. Okay, I think open world's the closest that we ever gonna get from real life architecture experiences, because in real life architecture we cannot control necessarily from which direction people will come, or where they're gonna look, how they're gonna move around. They are free to do as they please, just like in open world we have little control over the player. And once again, when I say control, I mean in terms of design, right? Directing the player to do what we want them to do, we have less control. So the definition here of an open world is where the player can roam freely through a virtual world and is given considerable freedom in choosing how or when to approach objectives. So you don't have uh, if it's a truly open world, open ended, you don't have a beginning and an end. Like you can approach any region at any time and you should do good. Okay, we're gonna see techniques that would prevent players from doing that because we want to have control over the experience usually. Um, but yeah, that's in a nutshell what it means. And here I have this example here from Ghost Recon Wildlands. This is a horrible game in my opinion. In terms of gameplay, is not fun at all, because although when we look here at the environment, it looks like we have a huge variety of encounters. So for example, we're gonna have a enemy base on the top of a mountain, maybe another one in the middle of the forest, another one in a crevice right there on the foot of the mountain or in the water, blah blah blah. That's not what we see here. In terms of visuals or the environment, yes, we have a huge variety of environment. But what I think is a big issue in this game for me is that most of the enemy hideouts, and that's probably the main quest that you're going to be offered over and over again, is to clear out those enemy encampments. They are usually on the top of a hill in a very well defended position, where your best strategy is usually just engaging sniping, and that's it. So that's why I find this game is very poor in terms of level design, because although the level looks pretty cool with a lot of different positions where you can place content, the designers, they chose to use the same strategy for every encounter. So it gets tiresome very fast, very quickly. And there are other issues in terms of pacing, in my opinion. For example, I was level 1 and I just found a chopper that I could use it, and then I use the chopper to just clear the enemies out. And I know that this chopper always going to spawn in that region every time that I reload the game. So it's kind of, yeah, not the best design. Oh, here's a nice. Can you guys hear the music in the extra credits here?
Yep.
Yeah. Okay. So let's watch this cool video showing techniques on how to develop open world level design.
A few weeks back, James was sitting down to dinner with a few of his designer friends, and they got to talking about an open world game one of them was working on. As they talked, they ended up discussing how they each conceptualized open world design. Today, we're going to go over the same problem, because it lets us talk about something we rarely get to discuss. The fact that sometimes, when designing, the most important thing is how you conceptualize the problem you're approaching. People can approach the same design problem and choose to solve it in radically different ways, depending on their perspective of the problem, which in turn results in radically different games. If you think of jumping over a pit as being about precision, you get Super Meat Boy. But if you think about it as being about speed, you get an Endless Runner. If you view action RPG combat as a way to make the player more connected to the character, rather than seeing it as a way station between moments of character development, you get Demon Souls instead of Fable 3. So it falls on us as designers, when we have the luxury, to examine our premises before we dive into the thick of the actual design process. So, open world games. There are at least two fundamentally different structures for thinking about how to construct an open world game. You can conceptualize it as a game made up of towns, dungeons, and open world encounters, or you can conceptualize it as a game made up of modules in the old D&D sense. In the first structure, you build out towns, dungeons, and encounters, and then you slot them into the world as they fit. In the second structure, you compose the world as a patchwork of loosely defined areas that each have their own adventures running through them. We end up using the Elder Scrolls series as an example a lot because it's the biggest budget, most marketed, longest running fantasy open world series out there, but it's a good example of the first design philosophy. None of us have worked with Bethesda before, but I'd wager that even their team structure is set up along these lines, with different people making the dungeons, towns, and encounters, and not a great deal of time spent coordinating between the groups to make areas of the world feel like holistic zones with their own adventures and multi-quest micro-stories running through them. Baldur's Gate, on the other hand, is an excellent example of the second design philosophy. Because the game itself is coming from a D&D pedigree, it makes a lot of sense that they look at open world construction in this manner. If you look closely at that game, you'll find that each of the zones on the map feels like a unified place with a mini narrative running through it. Personally, I feel like the second approach gets you a stronger result, as it lends itself more toward interesting encounters rather than simply hack-and-slash combat problems. It creates a framework that allows designers to craft a strong narrative in an open-world environment without losing the freedom of exploration that's so essential to open-world design. Of course,
just caveat here, I think both approaches, they are better together, actually. So think about each area, what makes this area unique, because if you have different areas, it's because they're different. So what makes one area unique in comparison to the other one, that's very important to keep in mind. And then so this will give the unique flavor to each area. And then you think about the quest that you can have in each specific area that talks to the specific design point that you want to point out, and also how they're all connected, how the player is gonna go from area 1 to area 2. Do they have to pick a boat, or can they just walk in that direction, or they have to go up in the mountain to find snow, and lower there's no snow, like in Zelda, for example. So there is no best way. The best way is the one that works for you, okay, in terms of design. But those are all good ways to approach the problem.
The problem with the module approach is that it's a bit tougher to pull off from a production standpoint. First, you have to organize your teams so that they're working together on entire zones, which requires a lot more communication and a lot more management overhead. Second, it means while you may be able to salvage some stuff here and there, you are a lot more likely to have to completely scrap a bunch of work if one of the teams falls behind, or their area just isn't coming together. This method also creates 2 design challenges for you. First is the obvious fact that creating holistic micro-adventures requires more work from your designers. The alternative of simply creating the constituent parts of those adventures, the dungeons, towns, and encounters, and then scattering them about the world, doesn't require as much design staff. The second challenge is in how you delineate the boundaries of those adventures within an open-world framework. Baldur's Gate took the technologically necessitated, but also simpler design approach of simply dividing the world into separate zones. They had boundaries between these zones, and whenever the player crossed them, the game would pause to do a bit of loading. This gave them an easy way to delineate the module or adventure space. That is much.
If any of you played it, Baldur's Gate 3, the way that they solved the same issue, they have a map that is loaded into memory. You play around the level. And once you reach the boundary, you get prompt with a message, hey, do you really want to go to the next region? And sometimes when you go to the next region, you also advance into the narrative. So some people who were in this first village, now they're going to move up, or they're going to travel to the following location. So there are many ways. But in Skyrim, for example, everything's seamless, right? If you played Cyberpunk 2077 or any other open world game more on the action side, like Elden Ring. Elden Ring, we have a great example. If you played it, you know that to reach some areas, you have to get an elevator. That's a good way to also unload everything from your memory, from the previous location, while the player is on the elevator. So you just keep the elevator on memory, and while you are dumping all the previous location from memory, you are loading the new location in memory as well. So there are many ways that you can do this. I would say that's not a problem or a big problem anymore. Maybe it could be an issue, but for our assignment and most of your level design in life, I don't think you should think about it. Okay, how are you going to transition from one zone to another? If you have, for example, a snow zone, if you're planning to have a snow zone in your island, for example, a tall mountain, I think what you have to think about is how you're going to go from no snow to snow. How is going to be this transition? So do you want to emphasize the transition, or is going to be a clear cut? Here is cold, here's not. So those kind of things, I think they're more important today. This is maybe a 10 years old video than the memory tricks to keep things flowing and this never changing. Or you're always inside the level, right? You're never in a loading screen. That's not a problem anymore.
Harder to achieve with the Elder Scrolls seamless world. Dark Souls 2, which feels less like an open world game to me, but I've had enough people insist to me that it is that I'll use it here. Anyway, Dark Souls 2 also creates clear zone delineations, but they do it through visual aesthetics and by having the zones actually all be spokes off of a central hub rather than a truly free roaming space. Dragon's Dogma, on the other hand, provides a more module-based experience than Skyrim within a true open world by having its content seemingly designed as areas rather than as pieces. It's basically an Elder Scrolls type of game with a more Baldur's Gate-esque module philosophy for their open world design, but even they didn't truly go all the way in creating the module-like feel of old Black Isle games. Instead, they settled for giving each area a unique sense of theme, tone, and design, but eschewed the series of quests and encounters that would make each area a small adventure in and of itself, with its own story to tell. Actually, some of the best modern examples of module-based open worlds come from MMOs. If you look at World of Warcraft, many of the zones there, especially later in the game, feel like unified adventures with little stories of their own. But they too couldn't do it without clearly defined zones. On the production side, I think all these problems are soluble so long as you go into the project thinking of your world as a patchwork of modules rather than simply a collection of dungeons, towns, and encounters. On the design side, it's something you're going to have to play around with in pre-production. It's easy to do the module thing with clearly defined zone borders, but without zone borders or artificial gating, making these adventures feel natural and keeping the player from getting lost in a mishmash of overlapping modules as they inadvertently cross between them is something that will probably require a unique solution for your game, as there's not a whole lot of successful examples to draw from. Oh, before we go, I wanted to say something about sandboxes. Often we seem to use the terms open world game and sandbox interchangeably. They're actually not, though. Sandbox games are games where you, the player, create part of the fun yourself by playing around within the world the game presents you. Games like these may benefit less from module-based design, because it's not simply the adventure itself that makes these games engaging. It's also in finding new areas to mess around in, and new ways to play with the systems the game gives you. Grand Theft Auto games get more mileage out of just building cool bits and socketing them into their world than a lot of fantasy open world games. Because in GTA, a well-placed ramp is a new toy for you to experiment with. You could spend hours trying to use it to land your car on an impossibly high building, or just enjoy throwing cars off it and laughing yourself silly. Whereas a random troll camp in an open world fantasy game simply can't be played with in the same way. So if you're thinking about creating an open world game, consider what your design approach should be. Do you want to conceive your world out of a patchwork of modules, or would you rather create a single huge space and sprinkle dungeons, towns, and encounters all over it? They both have advantages, and they both work. But I gotta say, I'm looking forward to seeing a game crack the problem of providing modules, mini adventures, and tiny...
Yeah, that's a pretty good video and a great explanation for the sandbox in there with visuals. That's good. I forgot that it was there. That's nice. Do I have here another?
Is perhaps my favorite of them all.
Okay, so this one I will recommend that you watch later. We're not gonna watch it again. I'm also gonna put here on our Discord channel, so under recordings, because all the good things go in there. But watch it later. This is an amazing channel, by the way, Game Maker's Toolkit, and he's gonna go over the magic of the first Zelda. Why it was so magical? Because everything was about exploration, and that's something that got a little bit lost and was revived with the new Zeldas on the Switch. Yep. Okay, let's get back here. Okay, so there are some ways that we can explore the design philosophy. Okay, so here just like a quick architectural, like real life architectural references. So the best place that I think you can draw inspiration from real life architecture to make open world level design is from amusement parks and landscape architecture. Why? Because those two archetypes of architecture, they are trying to solve the same issues that we are in games. We are trying to direct the player without really like pointing the way, so they use very interesting techniques to get there. um, I want to analyze here this amazing architectural building that we have in downtown Vancouver, the uh, what's the name of this building, the Vancouver Convention Center. There you go. So here, so we are about, where are we? Here, about here, Langley. We're about here, right? In Abbotsford. So if you come down to Stanley Park, here we have Cole Harbor area, and near Cole Harbor or near Canada Place, probably you know this one better. Here we have the waterfront station on the subway. We have this beautiful building here called Vancouver Convention Center. Geez, what is the button that I press here? Yes, there you go, shift to rotate. I told you, any new software, it's a pain. So this is from Google Earth. Let's analyze here this beautiful architecture piece when people come from the ships. Okay, so let's imagine we just dropped out the ship here on the convention center here, Canada Place. So we walk here down the street and we are placed right here. So that's a very iconic place in Vancouver for foreigners, right? Geez, so hard to move around in this software. Come on, okay, okay. So we are right here. I think I can use the little dude here to see better. Okay, so here we are. That's our view. So there is the ship we just dropped off. And we are here. Where can we go? Can I get a little bit closer to Canada Place? There you go. So here is a better. So we just dropped in here. Not the best because we are in the middle of the street. But anyhow, imagine that we are here. When we look around in that direction, we don't see much. That's literally the end of the street, literally the end of the city right here. So we get back here and go in that direction to Gastown. Here we have, well, the city, but not very inviting. But here's very interesting. Um, can I get there? Yes, that's awesome. Okay, so here's very interesting. When we look around, we're clearly gonna see that here we have city, here we have nothing, and here we have something interesting. So we have this nice building in there, and if we get a little bit closer, we see this Hadouken in there, which is quite enticing. So as rule of the thumb, people who land in here, they probably gonna follow the path in direction to the biggest mark that we have here. That is this beautiful building over there. So yeah, they're gonna keep walking, and as I mentioned before, the I think it's I don't remember the name of this art piece here. I think it's the drop or something like this, the droplet, but I call the Hadouken. They're gonna see the Hadouken in there and say, "Oh, that's pretty interesting. Let's walk around." Because, well, you know what? When you're traveling, you wanna walk around and know places, right? So let's keep walking here. So if we walk around, we get here in this corner, and in this picture we cannot see because of the sun. But here we have a cool earth. It's literally like an earth sculpture rotating here. It's very interesting. So everything that's visually enticing is something that will attract people to that location. So that's exactly what we're looking for in our level design. We're guiding the player how we are putting interesting things for them to look at and check, just like we have in here. So maybe they're gonna go there and check the thing, or maybe they're just gonna follow the flow here. There's a huge inflow of people down here, so we have a lot of commerce, and there is that thing over there. That's your end goal, the winner, as we're gonna see soon. Okay, so they just keep coming, and when they arrive here, they're still gonna look around and say, "Oh yeah, that's a pretty cool building." But when they get here, wow, they finish looking at the Hadouken, and they're gonna look around and say, "Oh, nice view. We have North Vancouver over there. Grouse Mountain somewhere. I think behind this pillar here is Grouse Mountain." So they're gonna be. Oh, now we are inside. Damn it. How do I get back? Go back? I don't think you can go back. Okay, good. So they get this nice view as a gift. And the planes are over there. The seaplanes is something that's not very common, so they're probably going to keep going. And also going back now, there's not a lot of point in going back, so they're probably going to keep going around this building here. So once again, we are directing people with interesting stuff. And here they're going to face a choice, right? They can either go up, and there is interesting things to do up there, or they can keep going and go around. So I'm just going to go around here because it's going to be easier in this street view. And here, once again, they review more visuals and they can see more of the city, Stanley Park, and they're probably going to be following this path here all the way down, and eventually they can even get into Stanley Park if they keep following the seawall here. Okay, so this is pretty cool. And here, once again, everywhere you look, you're gonna have some nice visuals. And eventually, I don't think we can get all the way down there. Probably not. Okay, so let me get back to the view. So once you are here, let's see if I can drop us here. Okay, cool. So once you are here, once again, you have the option to continue or come back here the stairs and keep exploring this region. So let's analyze the flow here. So now here I'm talking about people flow. Okay, um, so here is the square that we have on the top there. Here's the stairs that we checked before. Here's the orca sculpture. So people, let's analyze the flow here of people. We have here a lot of people coming from the ships and maybe even the subway over there, and coming around here. So they can come around here and go all the way there, or they can come around here and get to the square right there and come back here, or they come back up here and reach the square once again. We also have this street here, that's a main street coming all the way in here, and people will come here and they can choose going that direction or exploring this area. And also we have all people coming from the seawall, they end up here on the convention center. So we have a lot of flows directing people into this architecture space. And in the architecture space itself, we have a lot of options to distribute these people and give them interesting things to look no matter where they are. um, and of course, we have here the external areas, but we also have a lot of internal areas inside this building. And even the top of the building, although it's not open for public, but it's a region where you can walk around, or you could walk around and explore. So here we are giving people a lot of focal points to see and go after. And once they reach this location, we're going to present them with new focal points, new interest points to guide them to the following region. Does it make sense? I hope it does. So here, create an experience. That's very, very important, especially for landscape architecture and amusement parks and in games. That's all that we do. We are directing people around, showing through the easiest path, and also creating focal points that attract their attention. The landmarks, and so they know where they are and where they want to go. And finally, the idea of building a building from a feeling. So how you want people to feel when they are in this specific location, and how you're going to push them around. And also the idea of finding whatever is already there, because, well, the building is already there, maybe for 50 years or more, but you are uncovering it slowly for the first time for yourself. This is a nice video that I will welcome
The
you to
original.
watch, but as you can see, it's a huge video. When I teach just level design, we go over it, and I do my remarks and also skip to the parts that really matter, but I'm going to put here for you to watch later. But yeah, in a nutshell, let me find here an important part here. Let me see the beginning. Okay, so the way that most of amusement parks are created, they are based on the first theme park, or the OG theme park, the first Disney park. So they are designed in a hub way. So you have a main entry point, and many games, many open world games, they are also designed this matter. So you have a main entrance point, you have a hub area that will, maybe the entrance here, you already have an area, like a welcome area. Then you're going to have a main hub where you can see the different options that you have available in your exploration. You're probably going to have a main header in there. In this case here, we have the castle in the back there. So from here, you can look at the different areas and make a choice where you want to go. And you know that if you're ever lost and you want to find your way back to the other areas, you can always go back to the center and find your way. So this is a Paramount um, example here of uh, park designs. The Winnie, that's a very important uh, concept. So just like we've seen in real life architecture, so you have a focal point that's drawing attention to it, and we are curious things. We're gonna go after and see what is under it, what it is. Is it as big as I can see? So try to create curiosity, foster curiosity on your public. It's very good for welcoming their exploration. And well, we have other important stuff here, but I'm just gonna ask you to watch the video later if you're interested to see more detail. So here, once again, we don't have a lot of control over how the player is going to approach the problem. Here I have some examples of of
fantastic introduction and
how it's solved in different games. So in Zelda Breath of the Wild, it's really cool that the only direction that you are given is as soon as you start the game. Oh, we were pretty close. Yes, so that's the very beginning of the game. You start in a chamber, so you wake up in a chamber, you get out of this chamber, and this is what you see as soon as you go out of the chamber. You see the world around you. It's a huge environment, and then the camera will focus here on the right corner. You see a fire, like a like a oh geez, I forget the name now, but you're gonna see a fire pit with a guy beside it. So that's the only time that the game will give you directions where you should go. It's very clear that you should go reach that man, and once you talk with the man, you're gonna learn that he's gonna give you the task of finding Princess Zelda and saving everyone. But that's it. That's the only quest that you get a direct ask for it. Everything else you pretty much gonna explore and find yourself how it works. Let me see. I have other examples here. Oh, they're most yeah. This one we're gonna go.
This video is
over.
sponsored.
So this is the Ubisoft approach. Maybe Ubisoft is not the best example nowadays because they are going bankrupt, but not because their games are bad designs necessarily, but they lost their way, I think. It used to be big on the screen. I think now I have to download to show you. That's fine. Okay, so this is a presentation that they put together for one of the GDCs, one of the game developer conventions. So talking about open world, I'm just going to skip to the part that is really important, or their design approach. So here, one example of a linear progression in Prince of Persia. So you have basically one way to get to the end. And here in open world, we are pretty much free to explore in any way. A straight line is not necessarily the line that the player is going to do to reach the quest. So their approach is so this is how it looks like in real life. So they are designing several routes here for the player to take depending on the type of player or where they are. They're going to find their route here. So those are the main routes that they defined on their design. So the way that they approach progression is in a segmented way. And if you played any of the Assassin's Creed or Ubisoft games, you're gonna recognize this formula here. So here though, here it is. So we have the safe zone here. So it's probably like a city zone where you don't have many enemies around. Then you have a yellow zone that maybe you have enemies patrolling, but they're not really interested in you. Then you have a red zone or a orange zone. Then you have a lot of enemies, and if you're not really hidden, you're probably going to draw attention real fast. And here you have the quest zone where it's restricted, and if anyone sees you, you're gonna fight. Okay, there's no way around it. So they break the approach into layers, just like onions or ogres. Okay, and here, so they have also sprinkled assets here or elements to support the player. Okay, for example, we have the people that you can hire and mix among them. So there is plenty here on the yellow zone, so you can tackle the orange zone. But inside the orange zone, you don't have much protection. It's all by yourself. And here in the red zones, basically, uh, be silent or be ready to fight. Um, what I think is the issue with this approach here, we have a lot of like more things talking about it. So here's another, the outpost. This one's very common in Ubisoft designs as well. So you have the open world area, which is green here. So you have, I don't know, regular threat. Then you have a yellow area that is you have people surrounding and patrolling, and then inside that's the no-go zone. If someone sees you there, they're gonna attack you right away and ring the bell and bring reinforcements. My problem with this approach is, as you can see, we have here two very different games. We have Assassin's Creed, the first example, and here Far Cry, and the result is the same. So we have a very similar experience in the end, because if you're approaching the objective, you're gonna have more enemies and it's gonna be harder. And if you just run away from the center, you're gonna get an easier life. So that's my critique here to this approach. All It's the same problem as I described here on the presentation for this game here, Ghost Recon. All encounters, they are the same and they follow the very same logic. So that's why I don't like it very much. Is it bad per se? No, it's not bad by nature. It's just not really thoughtful. So you can try to break this into other ways to approach the problem, but yeah, it's still gonna feel kind of the same. What I think is the best way to approach this problem or to design those quests is having multiple quests. Let me see here, or Elden Ring. This is an amazing video that it's explaining why Elden Ring feels so different and fresh from other games, because instead of having a central point where it's harder or it gets harder as you get to your objective, they have a different approach where sometimes you're gonna have this exact approach, just like as Ubisoft. Sometimes it's more linear. You're in a cave and it's built more in a traditional linear style. Sometimes it's going to be encounters that vary over time. For example, enemies that have a specific route, and you can go after those enemies only in that route. Maybe we can see somewhere in here, like we have giants pulling a cart. Sometimes it's going to be a trap. Once you get into this location, now you're gonna have zombies popping behind you. So or sometimes they're just gonna trick you. Let me find here Elden Ring First Dragon. So this is probably the best location in the Elden Ring. I got it spoiled through the internet, so I didn't see it myself or experience it myself for the first time. But here it is. So you are exploring. There are these guys over there, just like we have enemies mustering in other locations. So you think, okay, those are easy dudes. They are multiple, but I think I can do it. So when you approach them, let's see what happens with sound. So the enemies, they were just the bait. The actual enemy in this location is this huge dragon that probably the first time you find it, you're gonna be totally unprepared and under level to kill it. So that's a very nice surprise. You learn very fast that you're not the biggest monster out there. There are monsters way bigger than you and they can kick your ass very easily. So that's very nice. It throws a lot of novelty into the mix. Okay, so I will welcome you to watch. I'm gonna make this presentation available for you, so I'll welcome you to watch these links here that I have on each image. Something else that I want to bring to your attention, in Red Dead Redemption is the only game that I've seen this pretty cool approach to open world design. So they have the things that happen in the story and all the things that we've seen before, but they also have I would call contextual quests. So let's say you are just coming with your horse down a path, and someone's gonna ask for help on the on the road, on the side of the road. When you stop to help them, maybe they're gonna jump at you and they're gonna steal your horse or try to kill you. Or someone who broke their leg and now you have to pick up this person, bring them to their home. They're far away. So there are those cool little side quests here and there that they only appear every once in a while. So it's they're not always there. They have to pop up in the world, and you happen to be nearby to experience those. So that's very cool as well. Adds a lot of novelty and flexibility to the systems in Red Dead Redemption 2. I think it's very fun. Okay, so here's my step-by-step how to design those open spaces. So let's say that we have this map here, and the first step is to understand the flow of your space. And here, when I say flow, once again, is how the people will flow from point A to point B. So in this case means most direct route. Let's say that here is my initial position and here is the final position. Okay, I want to bring the player in here. That's the end result. So remember, the fastest route between two objects is always a straight line. So in this case here, what we want to do, we want to break the straight line. And how can we do it? Well, we can do in many ways. For example, vertical separation, as we have here in this amazing game, Infamous Second Son for the PlayStation 4. It's probably the first game that came out with the console. It's a really good game. The other ones, they were better than this one, but this one's still very fun. Okay, so first thing, you have to figure out what is the axis that people will be following and try to reach in a straight location. And now we have to put on some obstacles. So now with the flow axis in place, we need to break the sight lines and direct route to add some emotion and challenge to the player. Here's possible to play with terrain heights, create obstacles, put on enemies or anything in between to just prevent the player to just doing the straight line and the easiest and not fun way to reach their objectives. Just like in this game, they do it a lot. Especially if you're walking around the street, it's pretty bad for you because you're gonna have enemies shooting down at you. So usually you search for high ground and go jumping from rooftop to rooftop. So that's one way that they directed the player in this game. Also think about the options that you can give to the player. So for example, you can break the direct path once again. So once it's broken, divide the remaining spaces and think, okay, this area here, maybe for this approach, it could be a more stealth approach. This other route that I have here could be a brawler mode for players who like the combat. And so think about the experiences you can create in the different options that you create. Or maybe you just have one option, make it put out some variety in there. So every small area needs to have a purpose to exist. They're not just there because the world is big, but maybe you're giving the player a nice visual of the environment, maybe you're giving them a nice challenge of ability, or maybe a puzzle, or I don't know. What are the smaller experiences that you are creating? Okay, so golden tip, think about side quests such as collecting objects, fighting tougher enemies, or finding things. Just go crazy. Okay, repeat the same object near and hmm? Oh yes, okay, so this one is to help players have a sense of scale. If you have the same object close to the player and further away from uh, the player will say, oh, if this light post here is this size nearby, I know that that one, that small one, well, it's probably because it's too far away, kind of. So it helps players to have a sense of scale. Always go from the bigger to the smaller forms as well. There's something called landmarks. They help us to not only figure out where to go. For example, this is a good landmark in the distance, so help us guiding to go in that direction. But also you remember that this face here is facing the direction we came from, so also help us to know where we are. And yeah, those are the big ones, and just about time. Okay, so let's quickly read the assignment. Do we have any questions? Maybe. Oh, okay. Yes, everything is being recorded. Okay, and if you have to leave because you have another class, that's fine. I always gonna record and I'm not gonna take attendance in the end of the class. Okay, so as I mentioned before, we're gonna be building an island open world map. So it's an island because it's supposed to be small. Okay, not super big. Of course, don't make a tiny island. Make it big enough that you can explore some different environments, but not a huge, like um, a whole continent. Okay. By completing this assignment, you're going to be able to understand the pillars of open world level design, create effective visual engaging design documentation, and develop a coherent structure for questing gameplay flow. So what you are asked to do, I want you to deliver a documentation explaining how your game's going to work, or not your game, but your level more specifically. So it's a level design. I need your level design pillars. So they are keywords that capture the sense of your level. For example, exploration, discovery, challenge, combat, whatever you want to make it. Level design vision, it's a paragraph describing the core experience of your level. Maybe it's a horror experience. Maybe it's, I don't know, discovery, exploration. You tell me, and how you kind of gonna deliver that. Level design references. So here, those are games that provide reference to the experience, and visual references. Those are games or places or photos or whatever. So visual references that allude to the visuals that you want to deliver. Okay, so here's how it plays. Here's how it looks. Bubble diagram, if you remember from MEDA 280, it's a simple diagram where you put the areas close by. So for example, we're gonna have a cave. The cave is close to the mountain. Maybe the mountain is just beside a village, but to the north of the mountain, we're gonna have maybe a swamp. So we make those bubbles connecting the areas. It gives us a lot of clarity how those areas are connected and how you're gonna make one end up into the next one. And then finally, your island layout, so top-down view. Things to include: main quests, okay, that uh, requires at least 2 locations to visit. So maybe you get the quest in one place, you have to visit a second place, and then you have to come back to the original place to deliver the message. I don't know. Secondary quests, okay, it could be like kill whatever number of enemies and come back here, or there's a hidden secret somewhere, or whomever solves the puzzle is going to get a candy. Whatever it is, for secondary quests is good to flesh out a little bit more of specific locations. For submissions, I want the things that are here, right? So this list here, that's what you're going to submit in a document. Okay, level design pillars, vision and references, bubble diagram and layout, description and second of main and secondary quests. Things to, oh, here's something very important. This playlist here, I have a lot of good videos about level design to do a deep dive into level design if you're interested. And also for guidelines that I don't have it here. I should have more additional guidelines. So in terms of gameplay, your character can attack, and that's it. Okay, we only gonna implement a simple attack. Enemies, we're not gonna implement. Okay, so don't think about enemies are simple destructible objects for now. You can think about better enemies, but we're not going to implement them. Okay, so don't. What I'm trying to say here is don't put your design, like the biggest quality in your design is not going to be the combat design. It's going to be the exploration aspect of your island. Okay, think about an exploration game for sure. And that's it. Let me let you guys know go, because